Hello everyone. In the following series of tutorials, we'll be looking at assembly programming. To start off with, in this tutorial, we take a quick look at the MIPS ISA and its various details before starting off to code. As with any ISA, MIPS also comes with its own set of registers. There are 32 registers in the MIPS ISA. The various names of the registers and their numbers and their usage is given in this picture. In order to perform very essential operations like input and output, be it input, reading or writing a integer or double, a string, or reading or writing from a file, MIPS provides what are called system calls. So here, this picture shows the first few system calls. A more comprehensive list is present in this particular link, which will be provided to you. In order to use a system call, you need to load the service number in this particular register V0. The service number is provided in the second column. After loading, you need to load any arguments if needed. The specifics of the arguments is given in the arguments column, and you need to issue the syscall instruction. If the particular system call returns any value, then the place where you need to look at for the result is provided in this result column. In terms of addressability of the memory, MIPS uses what is called byte addressable memory, where each address corresponds to a data of 1 byte. Contrast to this, there are ISAs which use word addressable memory, where each data word has a unique address, where a word is an entity of 4 bytes. So in order to load and store words and bytes, MIPS provides the following instructions. We have LB, SB, LW, and SW. The usage of these instructions is given in the examples. Like, suppose you want to load a word at address given by stack pointer +4 into this particular S3 register. Here is the instruction that you need to execute. And similarly for store and storing a word and loading a byte, etc. A very important part of a program is functions and function calls. Functions are basically modules that can be reused when required. It makes our code modular. So a function typically takes in some arguments and returns some value. There are two basic components in this procedure, where we have some code that calls the function, which is the caller, and the function itself that is being called is called the callee. So the caller passes some arguments and jumps to the callee. The callee then resumes execution. It performs some procedure and returns the result to the caller. So the callee must make sure that it's not overwriting any registers or memory which is needed by the caller. Otherwise, the program becomes buggy. In terms of the MIPS ISA, the arguments passed must be present in these registers A0 to A3. The return values should be present in V0 and V1. The caller uses the JAL instruction, which is jump and link, in order to call the callee, and the callee uses the JR instruction, which is jump register, in order to give the control back to the caller. Finally, we conclude with assembler directives, which are part of the assembly code. They provide directions to the assembler to take a particular action or change a setting. So they do not represent any instructions as such, so they are not translated into machine code either. Here is a comprehensive list of all the assembler directives. Some of the important ones that we'll be using are .ASCII-Z and .data. So basically, .data is the section where we put all the global and static variables in. We'd also be using .space_n, which allocates n bytes of space in the current segment. We'd also be using .text, which is the section where all the executable instructions go in. So please refer to this list in order to get a better understanding of all the directives. So that's it for this introductory tutorial. In the next tutorial, we'll be starting to write an assembly program in MIPS ISA. Thank you.